So, good morning, all of you. I welcome you all to this session, the last lecture probably on differential equations. So, basically, in this lecture, we'll try to see, forming partial differential equations and a few techniques, just 2-3 techniques to solve partial differential equations. And we'll see what are different types of partial differential equations. Okay. So, basically, there comes 2 types of questions from this particular chapter, partial differential equations in GATE exams. That too, they have been asked very less frequently. So, let us try to solve that things. Partial differential equations. Partial differential equations. Okay. So basically we have defined. Good morning, Monica. So see here. So what's a partial differential equation? Generally we have seen, correct? If the differential coefficients are involved with respect to more than one independent variable, then we call the differential equations as partial differential equations, correct? And we have seen this during the definitions of differential equation. And the definitions of degree and order is same for both ordinary differential equations as well as partial differential equations. And that's what we have seen in previous chapter, ordinary differential equations. Hello all. So please see here. Writing what's a partial differential equation and all. The equation or the differential equation, that involves the differential coefficients of dependent variable with respect to two or more independent variables. Is called a partial differential equation. Is called a PDE basically. Okay, so partial differential equation. Examples, as I have stated, during the course of ordinary differential equations, you can always write some differential equations that involve partial differential coefficients, correct? Something like 1 by alpha into dou square u by dou t square, whatever might be the things. Okay, so always these are partial differential equations of this kind. So coming to order and degree, they are same as per the definition of ordinary differential equations, correct? So now basically we'll straight away go for forming of the ordinary differential equations. Okay, so we'll go first the topic of forming of partial differential equations. Partial differential equations. So when forming ordinary differential equations, I told you that number of times you need to differentiate, means the order of differentiation is equal to number of arbitrary constants in the given solution, correct? So similarly here, if you see, first point I would like to write, if number of arbitrary constants in the solution, if number of arbitrary constants in the solution is equal to number of independent variables then we get first order PDEs. Then we get first order partial differential equations. Means basically the equation involves only P and Q. Only P and Q. let us denote with small letters. So P and Q. Okay, so I told you what is P and what is Q. Generally, if you take Z as any function of x comma y, if Z is f of x comma y, during introduction to partial differentiation in basic calculus, I talked a bit about this. So this P is nothing but dou Z by dou x, and Q is nothing but dou Z by dou y. Correct? Did we talk about this during the concept of maxima and minima of two variables? You remember this? We were giving you this concept at that time. Do you all remember this? We were talking about this at that time. If Z is a function of two variables basically, then P is nothing but dou Z by dou x, and Q is dou Z by dou y. Yes? And what about R? R is dou square Z by dou x square. S is equal to dou square Z by dou x dou y, and T is equal to dou square Z by dou y square. So these are the terms that we defined at that time, correct? So if this is the case, so see here. So basically, if the solution is having number of arbitrary constants same as the number of independent variables, then basically we'll involve only P and Q to form the differential equation, partial differential equation in general. But if number of arbitrary constants are more than the number of independent variables, then we'll go for high order differentiations like R, S, T. Okay. So now if you see, we'll write that point. If number of arbitrary constants are more than the number of independent variables, then we obtain higher order partial differential equations. Means basically then we'll involve terms like basically R, S, T, all these higher order differential terms. Okay, so now keeping these 2 points in mind, let us work out 2 examples. In GATE, questions didn't come from this topic basically, but there's a syllabus. There's in the syllabus. It's a part of syllabus to teach. So I'm teaching you higher order partial differential equation. So example: form a PDE for the function z is equal to x square plus a square into y square plus b square, where a comma b are arbitrary constants. So you have two. Yeah, this is new topic, Vinay. So please see here. These are two arbitrary constants a and b, and you have also 2 independent variables. So to eliminate these constants, the maximum differentiations you can do is p and q. Means you can differentiate both this function with respect to x and with respect to y only once. Means you should involve only first order derivatives, and you need to eliminate this a and b. So try to solve this. Think something. See, you should use p and q, which is dou z by dou x, and q dou z by dou y. Okay, using these two, you should eliminate this a and b from the equation. Okay, so please try out something and try to eliminate this a and b. But this is a very small topic. It gets finished within this lecture itself. Okay, and we may introduce a bit of vector calculus as well. Okay. So could someone try something for this? PQ by 4xy is equal to z. That's what you want to say, Kamaluddin? What is PQ by 4xy? What is that equal to? See, I asked you for an equation, but you are giving an expression. Okay, so see here, no issues if someone don't get this, since this is a very, first question, PQ is equal to 4xyz. Correct. So if you see, P is equal to dou z by dou x is equal to, so see here, for dou z by dou x, when you are differentiating with respect to x, you will treat that y square plus b square term as a constant. Correct. So this y square plus b square is a constant into differentiation of this x square plus a square is 2x. Okay, this is equation 1. Now, yes, PQ is equal to 4x/z, correct? Suma, Annapurna and all. So see here, Q is equal to dou z by dou y. So this is equal to, when you differentiate with respect to y, then you treat x as a constant. So x square plus a square into 2y. This is what you have. So 2. So from these two equations, you should think some mathematical operation to perform so that you will be eliminating these two terms. So if you see, you have product of x square plus a square into y square plus b square in the given question. So if you see, if you multiply these two, then it should come into your mind that when you have the combination of x square plus a square into y square plus b square, you can replace this combination with z. So to do that, what you need to do, multiply 1 and 2. So this implies, if you multiply both left hand sides, you have PQ is equal to, if you multiply both right hand sides, you have y square plus b square into x square plus a square into 2x into 2y is 4xy. And if you see, now to eliminate this combination y square plus b square into x square plus a square, this is nothing but z, which is given in the question. So if this is z, then you can have PQ is equal to 4xyz. Okay. Yes, Jyotsna, correct. So see here. So this is how basically you'll be forming differential equations. Generally, they are not asked in GATE examination frequently. Not even 2 questions have been asked so far, but it's good to know the things. Okay, so PQ is equal to 4xyz is one way how you could, solve for the things. Okay. Of course, I will discuss only first order solutions here in this case. I mean, first order solutions of only first order equations. Okay, is that clear to all of you? Okay, is that clear? How this is PQ is equal to 4xyz? I hope you all understood this. So can we move ahead for next things? When you start next chapter, sir, maybe in today's class itself by the end. Okay, we'll start vector calculus, and vector calculus is a really important chapter because it deals with geometry and all again. Okay, it's going to be somewhat interesting as well. It's not like this differential equations, because in differential equations, if you want to teach you geometrical significances of every solution, it takes a lot of duration, correct? So the main important thing in GATE exam is, as soon as you see the equation, you should be in a position to write the solution for that, and that's what we're discussing now. Okay, so this chapter will get finished by today itself. So let us see the things. Okay, so if you want to try one more question, I would like to give you one more question. Do you want to try that? Okay, so form the PDE for the solution. Z is equal to x square by a square plus y square by b square, where a comma b are arbitrary constants. So please try out this question. So you have 2 independent variables x and y, and also 2 arbitrary constants a and b. Okay, so please try to eliminate them and tell me the answer. This is y square by b square. Okay, so if someone have an issue with this, you can look at this b square. Okay, so one thing that is you need to calculate p and q, because I told you, if you have number of arbitrary constants is equal to number of independent variables, then only you can use first order terms, which means you can use only p and q, but you can't go for r, s, t values. Correct? So if you z is equal to px plus qy by 2, I hope that's correct. Z is equal to xp by 2 plus qy by 2. Okay, Suma, I hope both of you are correct. So see here, let me try to solve this question. We have z is equal to x square by a square plus y square by b square. Correct. So this implies p is equal to, which is dou z by dou x. If you differentiate this with respect to x partially, then this b is a constant and y is also a constant, which means this complete term goes to 0, because differentiation of this complete term whenever you are differentiating with respect to x is 0. So differentiation of this term with respect to x is 2x divided by a square plus 0, which is 2x by a square. So what about a square now? This a square can be written as 2x divided by p. Similarly, can you tell me what would be the value of b square? Similarly, yeah, I hope now you got things, how to perform operations, correct? So b square is equal to 2y by q, correct? Because if you differentiate with respect to y, then this first term will go to 0 and q will give you 2y divided by b square. So b square is equal to 2y by q. So using these two equations, you need to eliminate this a and b from this equation. So let us substitute there. So this implies z is equal to x square by a square, and the value of a square is 2x by p plus y square divided by 2y divided by q. So if you see, you can cancel one x all over here and one y as well. So this implies z is equal to px plus qy divided by 2, which means 2z is equal to px plus qy is the equation. Okay. So this is how you will be forming the things. Okay, so basically this is how you generally form partial differential equations when some solution is given to you. Okay, so now we'll see what is a linear partial differential equation, and straight away we'll go for solving process of linear partial differential equations. Correct. So we'll see that. Linear differential equation definition is same as in ordinary differential equations. Basically, you shouldn't have terms like z into d square by dz square and all these things. So if you want me to write, I can write linear PDE, linear PDE. The PDE is said to be linear. The PDE is said to be linear. See, definitions are almost the similar. Definitions are almost similar for the for ordinary differential equations and partial differential equations. That's why I told you the definitions like linear differential equation, order and degree of differential equation, all these things. But I didn't mention ordinary or partial there. Correct? So see here, the PDE is said to be linear if the PDE doesn't involve the PDE doesn't involve the terms containing higher powers of higher and second, third, all these higher powers of dependent variable and terms containing and terms containing product of dependent variable and its derivatives Example, the PDE capital P into small p plus Q into Q is equal to R. Okay, so is it audible now? Audible? Okay. So see here. So now it's audible. So I hope no issues. So basically, these are the functions which is in this form. Actually, some function of x comma y into p plus some function q into q is equal to r, where small p is equal to dou z by dou x and small q is equal to dou z by dou y. Okay, so this is a linear equations. So now generally we'll look at different ways to solve this. Basically, this linear differential equation, of course, linear partial differential equation. So let us try to see that. Solving linear partial differential equations. Okay, let the equation is of the form p into p. Okay, let me write this as capital P so that you can sense them clearly. P into p plus q into q is equal to r, where p, q, r are functions of x comma y alone. Means there is no involvement of z, are functions of x comma y alone. Okay, so now if this is the case, let us see how to solve. So once you get this equation, see, remember clearly I am putting this r on the right hand side. Okay, right auxiliary equation. See, auxiliary is the name which corresponds help. So by writing this kind of equations, they help out in writing the solutions. Okay, so the auxiliary equation as dx divided by p is equal to dy divided by q is equal to dz divided by r. Okay, so once you write this kind, once you convert your given equation in this form, you'll be writing the auxiliary equation as dx by capital P is equal to dy by capital Q is equal to dz by capital R. Okay, so now in this case, once you get this equation, you'll be having three sets of equations, correct? You can equate these two, or you can equate these two, or you can equate first and last term. So you have three sets of equation. Now from the above equation, okay, so first step, second step, from the above equation, equate any two sets of equations. Okay, so when you equate any two sets of equations, basically you'll be getting two differential equations, correct? See, if this is x and if this is q, if you are equating these two, then since p, q are functions of x comma y, you can always put these things together always. So sets of equations. Let the solutions of the two sets of equations be. Let the solutions of two sets of equation. Let the solution of two sets of equation be. Yeah, similarly like constraint maxima and minima case come again. So see here. So let the solutions of the two equations be. First equation is phi of xyz is equal to constant, and second one is psi of xyz is equal to constant. C2, for example. Let us suppose these are the two solutions that you obtain when you solve two sets of equations. Okay, so in that case, therefore, solution of the PDE is written as some function of the PDE is some function of phi comma psi is equal to constant. So this is how you will be writing the function, and in general ordinary differential equations, for the solution you'll be adding a plus arbitrary constant, correct? So that c doesn't matter to change the solution of the equation. Similarly here in partial differential equations, you'll be having arbitrary functions. Means basically when you're differentiating with respect to one variable, means for example, see, if I give you dou z by dou x is equal to 2x, then this z can be anything, x square plus some function of y. what term might be this function, it doesn't matter. When you differentiate with respect to zx, this will give you 2x and so on. So whereas in ordinary differentiation and ordinary integrations, you have plus some constant here, c. But here, in case of partial differential equations, we have some arbitrary functions. Arbitrary means, in general, any function in terms of y could give the same result, which I have stated here. Correct? So that's why the end solution will write it in the form of phi of psi comma constant. Okay. Okay. So this procedure is in general valid for solving nonlinear equations also. For example, if you consider this writing this auxiliary equation and all, solving a linear PDE, I wrote this whenever only this PQ are functions of x, y alone. But generally, when this PQ are functions of x comma y comma z, means basically when this equation is also nonlinear, you can still use this methodology. So in general, I would like to write solving first order PDEs. Okay, since I'm writing first order, since we are involving only P and Q, because this method can be generally extended for 3 variables as well, since it holds good for 2 variables. So you can always write x comma y comma z as well here. Okay, it need not be linear generally to use this methodology. So now the procedure remains same, because whenever this procedure is useful for solving both nonlinear and linear equations, we can simply write solving first order PDEs. Okay, so if this is the case, by equating any two, we'll be solving 2 sets of differential equations. For each differential equation, we'll be getting the solution separately. So writing those 2 solutions in some arbitrary function form is the actual solution for this. Okay, so I would like to give you one example for this, and we'll move for the next form of first order differential equations. So before going further, let us try to solve this example. Okay, since this is valid in general for 3 variables, I gave an example in 3 variables as well. So y square z by x into p plus xzq is equal to y square, where p is equal to dou z by dou x and q is equal to dou z by dou y. Okay, so let us try to solve this using that particular procedure. Okay, so since we are dealing only one question, so let me tell the solution for this. Given equation is y square z by x into p plus xz into q is equal to y square. Correct? This is the equation. So now if you compare, we have p is equal to y square z by x, q is equal to xz, and r is equal to y square. Correct. So this is the question that was given to us actually. So we have p is equal to y square z by x and q is equal to xz and r is equal to y square. What's the next step? Form auxiliary equations. Form auxiliary equations. Form auxiliary equations. So if you form auxiliary equations, then this implies dx divided by p, where p is y square z by x. Correct? And dy is equal to, dy divided by xz and dz by y square. Okay, so if this is the case, so now see here. First of all, let us equate any 2 things. So now from this set of equations, we should equate any 2 sets of equations so that we will be getting 2 different solutions. You can equate any 2. The reasons why questions don't come in GATE exam from this particular topic is in generally because solutions are not unique in general. Correct? Because if I consider these 2 equations and these 2 equations, I'll be getting some expressions. But if some other student takes these 2 and again first and third, his solution looks a bit different. But since this is an arbitrary function of any 2 sets of equations, every solution is correct. So it doesn't have a unique solution basically, because of the arbitrary functions that are being involved there. So, in GATE examinations, these kind of questions are not being asked because they don't have a unique solution in general. Okay, so which equations we shall equate? Let us equate these first 2. Okay, so equating, you can write equating, but you should know how to solve in general. So I'm solving for you. What's the first expression that you have? F of x square minus y square comma x cube minus y cube is equal to constant. Okay, that need not be the same solution for all of us, Suma, because it depends on the choice of the two equations that you are taking. So let me take first and two. So y square z by x and xz. So dx by y square z by x, and this is equal to dy by xz. So if you take these two equations, then what happens? This z gets cancelled off here. So this implies x dx by y square is equal to dy by x. So this implies x square dx is equal to y square dy. So if you see, this is in variable separable form of ordinary differential equations. So if you integrate this, you will be getting x cube by 3 is equal to y cube by 3 plus constant. So which means x cube minus y cube is a constant. So this is one solution for a given set of equations. Let us assume 1 and 3 again. So considering dx divided by y square z by x is equal to dz divided by y square. So if you take these two, for example, then what happens? This y square gets cancelled. Then you have x dx is equal to z dz. So if you see, if you integrate the things, you will be having x square by 2 is equal to z square by 2 plus constant. Let us suppose c2. So which means x square minus z square is also a constant. So this is second solution for the second set of equations that you equated. So we'll write the general solution is some function f of x cube minus y cube comma x square minus y square is equal to constant. Okay, so in general you can choose any two functions, any two sets of equations, but generally for that's why solutions can't be unique. But this is one way how we'll solve partial differential equations in general to obtain general solutions of them. Okay. So I hope now we understood how to solve first order differential equations. Now we'll go for two special forms of first order differential equations, which is called Clairaut's form actually. So we'll see that how we'll write the solutions if we have things. I'll give you two key points which are important actually. From these 2 points, they can ask you a question in GATE exams many times. Okay. So first point, if the PDE is of the form f of p comma q is equal to constant, if it is equal to 0, means basically the PDE is containing some equation which is involving only in terms of p and q. Sometimes you can face expressions like p square plus q square is equal to 1. Then pq minus 4 is equal to 0. Some equations like this, which are partial differential equations actually, because if you see, this is dou z by dou x and this is dou z by dou y and all these things, correct? So when you have these partial differential equations, still you would go for the solution in this case. Then the solution of the PDE is z is equal to ax plus by plus c, where a and b satisfy the equation f of a comma b is equal to 0. Because I want to tell you one important thing here actually. See here, in general I told you will be getting first order differential equations only if number of arbitrary constants is same as the number of independent variables. Did we mention this or not at the beginning of this lecture? So if that's the case, if you see this solution, it appears like there are 3 arbitrary constants in this, a, b and c. Okay, so a, b, c are 3 arbitrary constants, but if you see, there are only 2 independent variables, x and y. Okay, so the thing which I am telling you is failing, but actually one of these a and b can be replaced by using this relation. Means, for example, if I have things like this, example, if I give you something like solve root p plus root q is equal to 1, means if there is square root of dou p by dou x plus square root of square root of dou z by dou x plus square root of dou z by dou y is equal to 1. If this is one equation, then solution of this equation is solution of this equation is z is equal to ax plus by plus c, but you can eliminate either a or b using this equation. And I told you this a and b are satisfying this equation, so we have square root of a plus square root of b is equal to 1, which implies this b can be written as 1 minus root a whole square. So if you substitute this b in terms of a in this equation, therefore solution is z is equal to ax plus 1 minus root a whole square into y plus constant. Now we have only two arbitrary constants which are sitting in this solution. Okay, so this is the solution that we have, which is involving two arbitrary constants and two independent variables. As a result, we have only first order equations, means differential coefficients only of first order p and q. Is that okay to all of you? Did you all understand how to write solution for this partial differential equations? See, one thing I'm telling you clearly, in partial differential equations, generally we involve three-dimensional objects for drawing. So drawings and all I am not giving here at this moment because it takes a lot of time to us. And also, writing the solution is more important for us as far as GET is concerned than to know the background behind it. Okay. So is that okay to all of you? Can I move ahead? I want all of you to respond. I want some 48 online. So all of you please respond. Did you all understand how to write if this is the case? Okay. So we'll write one more thing. If the equation is of the form, let us eliminate this. If the equation is of the form z is equal to px plus qy plus some function of p comma q, means if the DE is of this format in general, like where p is equal to dou z by dou x and q is equal to dou z by dou y. Okay, so if this is the case, then the solution for this equation is then the solution for this PDE is given by z is equal to ax plus by plus f of a comma b, where a comma b are arbitrary constants. A comma b are arbitrary constants. Okay. So basically, if you have equation in this form, just replace this equation with a in place of p and b in place of q, and this form is called Clairaut's form. This is Clairaut's solution actually, and the equation which is in this form is called Clairaut's form. You see, in morning class, at the end of the lecture, I discussed what is Clairaut's form for a single variable. So if we have y is equal to x into dy by dx plus some function of dy by dx, means basically this can have nonlinear terms as well. Means basically if you take this as p, if we have some function in terms of p like this, some differential equation, then I told you solution is y is equal to cx plus phi of c. Correct? You remember this? Who attended my lecture till the end, they know this point in today's lecture, where c is arbitrary constant. So if there is some differential equation in this format in single variable, you have solution for this equation by replacing p with c actually. Okay, by replacing p with c. So this is called Clairaut's form in ordinary differential equations, and this is Clairaut's form in partial differential equations. Are we okay so far? So wherever you see px plus qy plus f of p comma q of the form, just replace p with a and q with b. Okay. because this question, once they asked in engineering sciences exam, engineering services exam, ESE exam, basically by giving z is equal to px plus qa plus some function they mentioned here. I remember it's p square plus q square. So they asked for the solution, and z is equal to ax plus by plus a square plus b square is one of the option in the prelims question paper of ESE. Okay. So I hope all of you understood how to write solution if the equation is of this form. Just replace p with a and q with b. Is that okay to all of you? I want all of you to respond. Yeah, nearly some 45. So please respond. If that's okay, then we'll go for next topic. Okay. So okay. So I'm happy that many of you are saying yes. So see here. We'll go for one topic, which is variable separable form. Variable separable form. Okay, so now we'll see what is this variable separable form, and this is the only way. I mean, this is the only method that we see in solving the partial differential equations. And after this, there exists some 20 minutes of lecture at which we'll close the session of partial differential equations, and we'll introduce vectors. Okay, so see here. Variable separable form. Now, what is variable separable form? You know, in ordinary differential equations, if the equation dy by dx is equal to some function in terms of x and y can be separated into variables, then you can work out the things in variable separable form, and you know how to integrate and write in the solutions. Correct? Did you all remember this? In the first lecture of differential equations, we have stated this variable separable form, and we have basically written this solutions for differential equations by solving them in variable separable form. So now let us see here how the variable separable form looks like. Okay, so straight away let me go for an example to show you how variable separable form looks like, because in exam these kind of questions are also very, I mean, they didn't ask till now, but in future if they want they can ask you, but we should know how to solve this kind of questions. Okay, so I'll deal one example for this variable separable form, and after this we'll go for something called classification of partial differential equations, which is important in syllabus of GATE. Okay, so see here. So this is the example. Okay, I hope this did come. Okay, so this is the example that I want you to know. Okay, so if the equation is of the form dou u by dou x is equal to 2 into dou u by dou t plus u, where u is some function of x comma t, correct? Because if you see, the partial derivatives are involved with respect to x and with respect to t, and it's given u of x comma 0. This is u, sorry, where u of x comma 0 is equal to 6 into e power minus 3x. So this is one initial condition that was given to us to find out any constants, if any. So how to solve this question? So let us see this. This is a first order, partial differential equation, and we are solving this partial differential equation using variable separable form. Okay, so how to proceed in variable separable form? I'll tell you the key points, and also I'll solve this question simultaneously. Okay, so solution. Now if you see, one thing is very clear, there are two terms that are involved here, which are dou u by dou x and dou u by dou t, correct? If dou u by dou x and dou u by dou t are involved, on how many variables this u is depending, and what are they? Please tell me, all of you. If you see the terms dou u by dou x and dou u by dou t, u is depending on how many variables, and what are the variables? Two and x comma t, correct? X comma t. Yes, all of you are correct. 2 xt, x comma t. So see here. So now choose a function. Choose a function u of x comma t is equal to some function of x into some function of t. Okay, where see, you know that the solution of this term will contain terms of x and t. So assume this function u as a product of two functions, where one function is a function of x alone and another function is a function of t alone, correct? So now this implies dou u by dou x is equal to, see, whenever you are differentiating with respect to x, this function remains constant, because this is a function purely depending on t. So this function remains constant, and you will differentiate this function. So let us write t of t, because this function with respect to t is a constant, and this is x dash of x, correct? This is what you have now. And dou u by dou t is equal to, now what would be dou u by dt? Dou u by dou t, can someone tell me what would be dou u by dou t? X into t dash, correct? See, x of x into t of t. If this is the function, then tell me what is dou u by dou t, all of you. See, 48 people are on live. Please respond. See, if you have function as product of x and t, then dou u by dou x is this t of t is a constant function when you are differentiating with respect to x, and you differentiated this function and you have x dash of x. Now, for what is this? Xt dash, correct? See, this dou u by dou t is when you are differentiating this function with respect to t, this function with respect to x is treated as a constant. So x of x into t dash of t. Correct? This is what you have. Yes. T dash of t. I hope some liking business is going on. Meanwhile, it's okay. So see here, all of you. Let me put this question like this. Okay. So I'll be writing some more steps here. So now, if this is the case, so let us substitute these two in this given equation. Okay. So this implies the given equation implies C. Now after taking, we have got these two terms, correct? Now after getting these two terms, let us substitute in the given equation. What is dou u by dou x? T of t into x dash of x is equal to 2 times of dou u by dou t, which is x of x into t dash of t plus u, and you know u is x of x into t of t. So now if these are the things, let us try to do something here. Okay, so if you see, let us bring this term onto the left. So if you bring that term, we have t of t into x dash of x minus x of x. This is what you have. And on the right hand side, you have 2 into x of x into t dash of t. Are you all okay till this point? Is it okay for all of you till this point? Is it okay to all of you till this point? Okay. Yes or no, all of you? Okay. So see here. So once you attain this, let us do something. What's the equation that we have? T of t into x dash of x minus x of x is equal to 2 times of what we have? X of x into t dash of t, correct? X of x into t dash of t. So now, see here. Now, let us do something. Let us bring this x of x here and t of t here. So we have x dash of x minus x of x divided by x of x is equal to 2 times of t dash of t divided by t of t. Now, if you see, this got converted to variable separable form, correct? Because if you see, the left hand side of the equation is completely in terms of x, and the right hand side of the equation is completely in terms of t, correct? Now, this is in variable separable form. So let us assume this is some constant k. Okay, because this is an equation and this ratio is equal. So let us suppose this equation has some constant k here. So this implies we can have two equations now. X of x minus this x of x divided by x of x is equal to k. This is one equation that is with us. And what's the other equation that is with us? 2 times of t dash of t minus, okay, divided by t of t is equal to k. This is what that is with us, correct? So now if you equate this to k, then you can equate each term to k separately. Now if you see, this is an ordinary differential equation because this k is a constant and here there are only functions of x. Similarly here, if you see, this k is a constant and these are only functions of t. So these are ordinary differential equations because there is no involvement of second variable in this equation and also in this equation, correct? So this implies x dash of x is equal to, see, if you multiply this x of x here, you'll be having k times of x of x plus 1 x of x will give you 1 plus k x of x, correct? Similarly here, if you see, this t dash of t is equal to k by 2 into t of t, correct? So let us write the things. X dash of x minus 1 plus k of x of x is equal to 0. So this implies t dash of t minus k by 2 into t of t is equal to 0. So now these are two first order ordinary differential equations. Correct? So if these are two first order ordinary differential equations, then can we write solutions for this? If you write auxiliary equation, see, even first order equations can also be solved using higher order theory that we have. So if you write the solution, you have solution as x of x is equal to c1 into e power 1 plus k into x. Similarly, what is solution here? T of t is equal to c2 into e power k2, I mean k by 2 t. So this is what. Yes, correct. So everything is fine. So t of t is this function that we have, and x of x is this particular part that we have here. Is that okay to you? So therefore, we can have u of x comma t is equal to x of x into t of t. So this is what we assume. So u of x comma t is equal to x of x. So c1 into e power 1 plus k x into t of t is nothing but c2 into e power kt divided by 2. So this implies u of x comma t is equal to, now see here, this c1. So see here, this c1, because we are dealing variable separable form, so we want to separate this equation into variables. Okay, so see here. So see, this c1 is an arbitrary constant and c2 is also arbitrary constant. So the product of c1 and c2 is again a constant, c into e power 1 plus k into x plus kt divided by 2. Okay, this is what we have as a final solution of this differential equation. Okay, so this is how you will be working out the things in variable separable form. Okay, so things generally go big a bit, so that's why they are asking only questions. Only one time it was asked, that too from these kind of things, Clairvoyant's form and the other form that we discussed today, this particular two. So questions are generally coming from these two kind of models, but generally variable separable form, they don't ask in GATE examination. So see here, now we have initial condition u of x comma 0 is equal to 6 into e power minus 3x. Correct? So if you do that, u of x comma 0 is equal to 6 into e power minus 3x. So which means if you put t is equal to 0 in this equation, you will get what's the value of k. Okay, so this implies u of x comma 0 is equal to c into, because c is a constant, so e power 1 plus k into x plus, when you put t is equal to 0, this term disappears, and this is given as 6 into e power minus 3x. So this implies c value is 6, and if 1 plus k is minus 3, then what about k? K is minus 4. Okay, now we identified what are the constants that are with us. Yeah, k is equal to minus 4. So therefore u of x comma t is equal to, c value is 6 into e power, if k value is minus 4, this is e power minus 3x, and if k value is minus 4, then this is minus 2t. So this implies u of x comma t, which is the solution of this question, is 6 into e power minus of 3x plus 2t is the solution for that particular equation. Okay, so this is how we evaluate solutions in partial differential equations. Yeah, 6 into e power minus 3x into e power minus 2t. Correct, Monica? So this is how generally you'll be working out variable separable methods for solving partial differential equations which are of this form. Okay. Are you all okay with this? Did you all understand how did we proceed in solving this problem? First of all, we converted this into variable separable form, and then we started working out the things. So, but generally procedures are big, so that's why they are not being asked in GATE examination for past many years. But in olden days, yeah, it's lengthy. But in olden days, when GATE was descriptive examination, they gave that. If you have 3 variables but of first order still, then you can always go for this method. Okay, solving first order linear equations method. Okay. Monica, you understood now? If as long as the equation is first order and if you have functions of x, y, z, then you can always go for this particular methodology. Okay, Balanjali, you want how I got these values, correct? Let us suppose you have a differential equation. dy by dx minus 4y is equal to 0. Okay, so now if you see what is the auxiliary equation for this, m minus 4 is equal to 0, correct? So this implies y is equal to c1 e power 4x, correct? Yes or no? Did we talk about this? Basically, if you solve this equation, you will get the same thing. See, dy by dx is equal to 4y. So 1 by y into dy is equal to 4 dx. So if you integrate the things, integral both sides will give you log y is equal to 4x plus constant. So y is equal to e power 4x plus c, which can be written as e power 4x into e power constant. This is again a constant. So c into e power 4x. Okay, so if you solve the first order equation, this is what you will be getting. But using the theory for higher order differential equations, you can write auxiliary equation even for single variable functions, and you can work out the solution. Y is equal to c1 into e power 4x is same as y is equal to c into e power 4x. Okay, clear so far? Can we go for next things? Now I hope you understood how I would just Balanjali. See here, because if this is the function, then it's of the form dx of something with respect to one variable minus 1 plus k is a constant into x of x is equal to 0. Similarly here. I hope all of you are okay with this now. Okay, it's a bit lengthy. Yeah, I agree, honestly, but this is how we generally solve partial differential equations. Generally, in this course, we don't go for partial differential equations of higher order for gate exam, as far as gate exam point of view. But generally, in our research, we go for that. Answers for a few problems will come in some 5 to 6 pages even. Okay, so partial differential equations is not a bit simple. It has a lot of geometrical significances in general, because all the physics that happens changes. Suppose if this is the some solid, if I'm heating this, then the temperature, molecular motion, all these changes at the same instant. It's not like all properties are constant and one property change at a time. When you start doing something, all properties start changing at the same time. So we are more interested in partial differential equations when we go for advanced applied mathematics, like generally heat equations and all these things. Okay, so now from the topics that we saw, that I taught you till now in the first 1 hour of this course, it's already 11:30, 1 hour is finished. So see here, the main important thing that I told you is how to form a differential equations, of course, of first order, I agree. How to form a first order differential equation, then how to solve first order differential equations using auxiliary equation, where we take dx by p is equal to dy by q is equal to dz by r, and we have seen that. Then we have seen two special kinds of equations which are of the form, it is buffering sometimes. Is that the same problem with all of you, or is the video going fine? I hope there's some net issue with you, Pawan. So is that okay to all of you? Is anyone having the same issue? Gayatri, you're also having the same issue? Apart from you, how many of you are having problem with video? Please tell me clearly. No. Okay. So I think few of your net connection is not good. Actually, in south there is monsoon that's in forecast, so there could be some issue with the signals and all these things. Okay, so we have seen then two special kinds of equations, which is of the form f of p comma q is equal to 0, and second equation is of the form Clairaut's form, correct? Z is equal to px plus qy plus f of p comma q form. And after that, now we have seen how to work out the things clearly in variable separable form. Yes or no? So now, if questions come in gate exam in general, from these kind of questions will sometimes given with options. Okay, and if options are given, you can check easily which option satisfies the given equation on this given condition. Okay, so there is no issue. But if you are not able to solve, then this method which I told you now could help you in gate exam. Okay, but generally till now there's nothing such kind of thing that's happened. But in general, if they can give in one way. They'll give you the question, they'll also give you the options and they'll give you some initial conditions so that your 2 to 3 options will get eliminated when you check the initial conditions. Okay, is that fine? So can we go ahead? Can we go ahead now? Is that okay to all of you? Yes? Okay. So see here. So now, so in GATE examination, from the topics that I taught in partial differential equations, if questions can come, they can come from three particular spots. First spot is, as I told you, the equations of form f of p comma q is equal to 0. Second spot is the Clairaut's form. If they want, they can ask you questions from Clairaut's form. Third form is in variable separable form. They can put simple differential equations by giving you some initial conditions and options. Okay, where you could easily work out the things. So now we'll go for one really important topic. Many times, if questions comes from partial differential equations in the past, if you analyze previous papers, many times question came from this particular module that I'm going to teach you now. Okay, but I'm not sure whether it's going to come in 21 or not, but definitely it's the most frequently asked topic in GATE examination. Okay, so see here. Classification of PDE actually. Classification of PDE. Okay, so let us try to solve this. The equations of the form A into dou square u by dou x square plus B into dou square u by dou x dou y plus C into dou square u by dou y square. This thing which I am writing is really important for GATE, and 8 times out of 10 times questions comes from this particular thing. Okay, so please write down A into dou square u by dou x square plus B into dou square u by dou x dou y plus C into dou square u by dou y square plus D into dou u by dou x plus E into dou u by dou y plus f into u is equal to g, where a, b, c, d, e, f, g are constants, or they can be functions as well. Is the equation of the form is A elliptic. Okay, let me write. Is elliptic if b square minus 4ac is less than 0. B parabolic if b square minus 4ac is equal to 0. C hyperbolic if b square minus 4ac is greater than 0. Okay, so basically they'll give you some equation and they'll ask you the given PDE is, and options could be something like elliptical, parabolic, hyperbolic, and cycle, some other geometric figure they give you, but actually the answer lies in one of these three. Okay, so this is the condition. So if you know this A, B, C values, it doesn't matter what are the other terms. If you know, in today's class it will get completed, Suresh. So see here, if you know these values of A, B, C, then definitely depending on these conditions, you will tell the equation is elliptic, parabolic, or hyperbolic. Actually, why these names elliptic, parabolic, hyperbolic are given? If you go into a little depth, if you form the solution of a differential equation, of the partial differential equation generally, the curves, the equation of the curves, if you plot, you will be getting some shape. Okay? And these are the shapes of that particular curves of where, I mean, these are the names that are given to the curves that appear when you plot the solutions of the partial differential equations. Okay, clear how to identify a partial differential equation is of what kind? So there are basically three kinds: parabolic, I mean elliptic, parabolic, and hyperbolic. Okay, is that clear? So we'll work out some examples on this, and after that we'll introduce three kinds of equations, basically wave equations, heat equation, and Laplace equations, and we'll end this module of partial differential equations. Okay. Is that okay to all of you? Can I move ahead now? If yes, please say yes, we'll move ahead. Okay. So, first of all, I would like to write one equation which is called wave equation. Wave equation. See, right now I don't give you the solutions for heat wave and Laplace equations, but I let you know what are those equations and what are the kinds of those equations. Like basically they're elliptic, parabolic, or hyperbolic. We'll see now. Okay, in today's class. But generally, I'm telling you in wave equation. Because for writing the solutions of these wave equations and heat equations, you need to have some knowledge on Fourier series, which I didn't teach you yet. So at the end, when I teach you Fourier series, I'll give you the solutions of this wave equation, heat equation, and as well as our Laplace equation in general. But right now, I don't give you the solutions. I'll just let you know what are the equations and what kind of equations are they. Because in GATE examination, they asked you, they gave wave equation and they ask you the wave equation is of the form elliptic, parabolic, hyperbolic, and some other geometry. Okay, so that's why these questions are really important in GATE examination. So I would like to tell the things. Okay, so not what is wave equation. The equation of the form. The equation of the form c square into dou square u by dou x square is equal to dou square u by dou t square is a wave equation in one dimension. Okay, so this is the form of the equation. So basically it depends upon x and t. If you would like to talk a little physical significance of this wave equation, I would like to explain. See here, let us suppose there are two supports between which a string is tightly pulled and held firmly. Okay, so definitely when the string is tightly pulled and held between the supports, definitely there will be some tension T in the string. Yes or no? Because definitely when you pull something and if you tie that, definitely there is some force in that string. Now definitely the string, let us suppose this is of length L, then this string has a mass M. Okay, so let mass is equal to M and length is equal to L. Of course, when it is stretched, then there is something called a linear density, which is mass per unit length. Okay, so when there is mass per unit length, we define something called c square, which is T by M. Okay, now let us suppose U is the deflection at location T, at location X at time T. See, because if you pull the string and if you leave, what happens? String vibrates. Correct? When a string is tightly like this, if you pull the string a bit down and if you leave, then the string starts vibrating. Correct? So let us suppose this is your x-axis, and when you pull the string, let us suppose this is the shape of that. After some time, what happens when it is vibrating? It vibrates up and down. So definitely the string, the particle which is here at this instant will go here after some time. Yes or no? Means if you want to know the deflection of the string at a distance x, definitely you should know what is x, because you should know the point at where you need to find the deflection, and also along with the displacement x, you also need to know at what time. Correct? Because if you see at same position x at two different times, the position of this point on the string is at two different places. Correct? Because string continuously vibrates. Okay, so if you see here, Ravindra, when you're saying m by t, this c square is here, doesn't matter, it's just a matter of constants. Okay, so this is the case. So if this is the case, so for knowing deflection at any point along with direction, you should also know time interval. Correct? So which means this deflection is depending on two variables. location x and t, which means this u, the deflection, is depending on two independent variables, correct? So when this is depending upon two independent variables, definitely it involves some partial differentiation with respect to each variables. Okay, so you have derivation for that, but right now I'm not going for derivation because that's a matter of 11th class physics and all. So we are writing this c square dou square u by dou x square is equal to dou square u by dou t square. So if you write the equation now, so if you write the equation, the wave equation is c square dou square u by dou x square minus dou square u by dou t square is equal to 0. Correct? So now if you compare one thing, if you calculate b square minus 4ac is value, now if you compare this with a into dou square u by dou x square plus 2b into b into dou square u by dou x dou y plus c into dou square u by dou y square plus some function involving all the terms dou u by dou x, dou u by dou y, and u and all these terms. Then if you compare, the value of b is 0 here, correct? Because if you see, there is no term called dou square u by dou x dou t in this equation. When there is no term like dou square u by dou x dou t in this equation, then this value of b is 0, correct? Now if you calculate b square minus 4ac value from here, it's not changed. Okay, so on comparing a is equal to c square, b is equal to 0, and c is equal to minus 1. Don't get confused between this c and this c. This c is something that we used in wave equation, and this capital C is the notation that we used in writing general form of partial differential equation. Okay, so if you calculate b square minus 4ac, what's the value that you're having? 0 minus 4 into a value is c square, and this is minus 1. B square minus 4ac value, so c is minus 1, so this is 4c square, and c square is always positive, so this is always greater than 0. Okay, so 4c square is always greater than 0, which means this wave equation is of hyperbolic nature. Okay, clear to all of you? So this wave equation you can write clearly. Wave equation is hyperbolic in nature. Okay, generally wave equation is hyperbolic, heat equation is parabolic, and Laplace equation is elliptic in nature, if I want to take. So this question they asked it many times in examination. They'll give you one equation like this, which is basically wave equation. Then they ask you the nature of the following equation is options: elliptic, hyperbolic, parabolic, and some other geometry they'll mention. Screen is not clear to you, Vinda. Is that the problem with some of you? Because the c square value is greater than 0. Is the screen not visible to you clearly? But I hope in my testing it's okay. It's going fine. It's clear? Okay, then I think Sai Venkat Sai, you have some issue with internet connection, so please check that. Okay, visible? Okay, so see here. So wave equation is hyperbolic in nature. Okay, so solution of wave equation I'm not giving now, because you need to know something called Fourier series to write the solutions of the wave equation. So I'll deal the solutions when I teach you Fourier series at the end of the sessions. Okay. So, but for now, I would like you to know that this is wave equation in one dimension. Okay. So we are moving ahead. Can I move ahead now? Can I move ahead for the next equation, which is heat equation generally? If it's clear, please say yes. We'll move ahead for the next type of equation. Okay. Wave equation. sorry, wave equation we already finished. Heat equation. Okay. Heat equation. So basically we'll discuss heat equation single variable again. The heat equation of the form, the heat equation of the form, or you can write the equation in generally for the beginning, the equation of the form dou square u by dou x square is equal to 1 by alpha into dou u by dou t is said to be heat equation in one direction, basically x direction here. Okay, since we are dealing dou square u by dou x square terms, basically in this particular equation this is in x direction. Okay, so see here. So now basically if you try to see the nature of this equation, where generally u is the temperature and x is the location at a point and t is the temperature, so and t is time, small t is time. Okay, so for example, if you see, let us consider one thing here. I want you to tell this in a bit, good way. So let us suppose I hope the board is a bit less responsive again. Okay, so see here. So let us suppose there is one small plate like this. Okay, so this small plate, what does it happens in this small plate? Let us see. Let us suppose this is the x direction in the plate. Okay, so now let us suppose I am heating this plate by some source. When I am supplying heat, what happens? Temperature of this plate increases, and definitely because of molecular motion and all these things, temperature keeps on increasing. Correct? Now suppose if I take this as my origin, okay, this is y, this is x, so this is 0. Then what happens? By the time I start heating, initially the temperature here will be something. Correct? The temperature here will be something, but as time increases, what happens? Heat gets transferred. The temperature which is initially T1 at this point will change to a new temperature T2. Yes or no? T2 is generally higher than T1 because of heating. So which means if you want to know the temperature at any location on this bar, you need to know two things, which is first thing is the position of this point from this source. Second thing is the time at which you are measuring this temperature. Correct? Because at the same point with respect to time, temperature is changing. Means basically it is called unsteady state in terms of mechanical engineering. But if you see, this is called unsteady state heat conduction in one direction, and this is the equation for that. Dou square u by dou x square is equal to 1 by alpha into dou u by dou t, where u is temperature and x is the distance that you are interested to find the properties. Okay, so basically this is how one-dimensional heat equation is given to you, and if you want to know the nature of this equation, you can always work out the things. Given equation is dou square u by dou x square minus 1 by alpha into dou u by dou t is equal to 0. So comparing with standard equation in the sense the equation that we have, capital A into dou square u by dou x square plus B into dou square u by dou x dou y plus C into dou square u by dou y square. If you compare with that standard equation, what's the value of B? 0. Correct? A value is 1 because there is 1 here, because there is no dou x dou t term here. So value of C is also 0. See, be careful, this is not square. Okay, this is dou u by dou t term, but you should have dou square u by dou x square coefficient, dou square u by dou x dou y coefficient, and dou square u by dou y square coefficient also. So if you see, this c is 0. So what is the value of b square minus 4 is here? 0, correct? So b square is 0 minus 4ac. So when you multiply with c, this is also 0. So if you want me to shorten this a bit, we can look out. Okay, so this implies b square minus 4ac is equal to 0, which means this implies heat equation is what is heat equation? What's the nature of heat equation? Can someone tell this? Nature of heat equation is ellipse. How? Parabola, correct? Yes. Suma, please see carefully. I gave you the conditions. When b square minus 4ac is equal to 0, this heat equation is parabolic. Okay. So generally, if you solve for temperature profiles of these equations in one dimension, you will be getting, parabolic profiles for these things. So heat equation is parabolic. So wave equation is hyperbolic in nature. Now if we talk a bit about Laplace equation will deal more clearly when we come to complex calculus, because in complex calculus this Laplace equation has a good importance in proving some relation called Cauchy-Riemann equations and all these things. But for the time being, I would like to just give you the equation and show you its nature is elliptic. Okay, so see here, Laplace equation. Laplace equation. The equation of the form dou square u by dou x square plus dou square u by dou y square is equal to 0 is said to be Laplace equation in two variables. Laplace equation in two variables. Okay, so basically the functions which are satisfying this Laplace equation are called harmonic functions, which we deal in complex calculus generally. So basically this equation of this form, see, I just want you to know that this is a partial differential equation of second order, because it's involving some terms like dou square u by dou x square plus dou square u by dou y square, all these terms. So this is basically second order partial differential equation, and this second order partial differential equation, if you look at the nature, comparing, if you call this equation as one, comparing one with a into dou square u by dou x square plus b into dou square u by dou x dou y plus c into dou square u by dou y square plus some function of dou u by dou x, dou u by dou y, and all these terms, u is equal to 0 if you consider these terms, because degree is basically depending on these three coefficients a, b, and c. So whatever might be the coefficients of these terms, it doesn't bother much. So we are writing this as function of dou u by dou x, comma dou u by dou y, and u is equal to 0. Okay, so if you see this, we have, if you compare these values, we have a is equal to 1, b is equal to 0, and what about c? Again 1. So this implies b square minus 4ac, which means 0 minus 4 into 1 into 1. So if you see, this is minus 4, which is less than 0. So Laplace equation is elliptic in nature. So Laplace equation is elliptic in nature. And many times if question comes from one of these three boxes that I have done. So basically wave equation is hyperbolic in nature, heat equation is parabolic in nature, and Laplace equation is elliptic in nature. Yes, correct, Vasvi. So these are the things that's happening here. And questions, nearly some 10 to 15 questions have been asked from this classification of partial differential equations that we are discussing for half an hour. Okay, now it's 12 o'clock already. So I would like to end this discussion on partial differential equations here. So basically, before closing this lecture on partial differential equations, basically questions can come from four particular topics. First thing, the special form of f of p comma q is equal to 0, for which we define the solution as f of z is equal to x plus by plus c. Then we have defined some equation called Clairaut's form, where z is equal to ax plus by plus z is equal to px plus qy plus f of p comma q. Then we've seen how to write the solution for that. So that's the second part. Third part, they can give you simple questions from variable separable form, where they will be putting up some partial differential equations with some initial conditions, and they'll provide you options so you can clearly check and you can answer in a simple way. Fourth topic, it would come for this partial differential equation classification. Okay, so did you all understand what I told you in today's class? Basically, proofs I'm not going to give you for partial differential equations, because drawing three-dimensional figures is very difficult on this board, and drawing three-dimensional figures is really difficult on this board, and of course that's not needed for GATE exam syllabus if you see in a deeper way. Okay, PDF of thermodynamics I have already sent to concerned persons, so you can find it in the group shortly. Okay, anyhow, we'll discuss about the thermodynamics course tomorrow, but let us constrain ourselves to mathematics now. Okay, is that fine to all of you? Is that okay to all of you? So if you say yes, I'll start a bit of vector calculus. Basically, introduction about vectors and all, because I need to show you there are many. I got special requests for my contact. I got some special requests for my contact that sir, we are from diploma and we need some introduction of everything. So I would like to give some basic introduction of vectors today, if you're okay with this. Okay, so just a minute, we'll come for vectors. Okay, so now I'll give you some basic introduction on vectors. Okay, so we'll start vectors now. Okay. Okay, so we'll see now. You know what is calculus? Correct? What is calculus? Calculus is basically science of variation. Correct? Means we see with respect to quantities how other quantities are changing. Basically the differentiations, integrations, we have talked enough about it. Now what is a vector? That's the definition I want from you. You might be studying this since your class 11 or 12. So please tell me what's a vector? All of you. So today I'll provide differential equations notes by today evening or tomorrow evening, no issues. And I'll provide some practice. These questions also, practice questions as well. Okay. Magnitude and direction. It tells the magnitude and direction of a quantity, which has both magnitude and direction. Along with magnitude and direction, it should also obey one thing, which is called triangle law of vectors. Okay. So which has both magnitude and direction. Okay. So vector. A quantity whose magnitude and direction is well known. In general, a physical quantity. Correct? Both, like if you see physical quantities which are having magnitude and direction, like force, acceleration, velocity, all these things comes under this. Yes, vector calculus is important for mechanical, civil as well, and this is a really important concept to all other disciplines, because you'll be solving some circuit diagrams based on vectors as well. Correct? So see here. So now, before starting vectors, it's better if you have a bit knowledge about three-dimensional geometry. So I'll ask you some questions, so please try to answer them. Okay, so let us try to draw some figures. Okay, so let us suppose this is x-axis, y-axis, and z-axis. Okay, so now this point O is origin. Now, if I give you the length of this edge is A, length of this part, this edge is B, and if I give you height, basically this vertical edge of this solid is C. Now, can you please tell me what is this point? Any one of you? I hope the diagram is very clear to you. X comma y comma 0. See, I gave you some numbers A, B, C. Okay, so please tell them. The point is on xy plane. If the point is on xy plane, see, do you all understand? First of all, see, let me tell you one thing. Yes, AC is 0. Okay, so see here. If you see, this point which I plotted is on the xy plane, correct? And this face, this outer face which I'm hatching here, this face is coming out of the box. So if you see, this is A comma C comma 0. See, the equation of xy plane is z is equal to 0. So let us write these things. The equation of xy plane is z is equal to 0. Next, similarly, what is the equation of yz plane? The equation of yz plane is x is equal to 0. Similarly, the equation of xz plane is y is equal to 0. Okay. So now see, if you see this point that I mentioned, let us suppose this is capital A, then this capital A is lying in xy plane. Means, for example, if you take this board as the xy plane with origin lying here, and let us suppose this marker which is here pointing outward, is the z-axis. Okay, so something like this. Is that clear? For example, if I put this here as z-axis, this marker is in the positive direction of z-axis. So if you see, this point A is lying on the xy plane, which means its z coordinate is 0. Correct? So if you see this point B is lying on y-axis. If point is lying on y-axis, what are the x and z coordinates of that point? If point is lying on the y-axis, what about x and z coordinates of the point? 0 and 0. So x value is 0 and z value is also 0. But since it has a vertical height C, this point is C. Okay. So this point is origin. There is one more point on this xy plane. Let us call this point as C. So what about this point? Yes. So what about this point? Point C? A 0 0. Correct? So if you see A 0 0, because this point is on x-axis, so y and z coordinates are 0. Now we finished the points which are on xy plane. Correct? Now 4 points are coming out of this xy plane, means we are having some z coordinate. So if you see, for these 4 points on xy plane, you got this z coordinate as 0 in all the 4 points cases, because the equation of xy plane is z is equal to 0, and for any point that you take on xy plane, z value is 0. Okay. So now if you come for this point, let us name this as D. Now what are the coordinates of this point? This point is on yz plane. Correct? Can you sense that this face yz is containing this plane? So this value is What is this value? This is on yz plane, so x is 0. So 0 comma height of this point from base is c, and this dimension outward is b. So 0 c b. Correct? Are you all understanding, clearly seeing the things geometrically what's happening? So next, this point. This point is a point on z axis. So if this point is on z axis, what about x and y coordinates of this point? 0. Correct? So 0 comma b. Yes or no? So now, if you see, there is one more point which is lying on this plane xz. Correct? This x got merged with this point. So let me write it separately. So x. So now see here. If you see about this point f. Now this point is lying on xz plane. So if this is lying on xz plane, what is the value of y? 0. Correct? So from origin it is at a, and from in the z dimension, the dimension is b. So a 0 b. Now if you see, there is one point which is lying purely in space, means it's not on any of the axis and it's also not on any of the plane, but it's getting protruded out of all the 3 planes. So this point has the value of a, a, and basically c, and then b is the z dimension. Correct? A, c, b. So this is how you'll be plotting all the points in the coordinate system. Basically means I told you this example because ACB is correct, all of you, Vasvi, Hema, Monica, Kamaluddin and all correct, Pavan. So see here, so if these are the points, now you should be in a position to identify how to spot the points in 3 dimensions. Means you should clearly observe which point is on which plane and which point is on which axis. Okay, so if you know that particular things, then it's very much easy for you to identify 3-dimensional things. Okay, so see here, if a x1 y1 z1 and b x2 y2 z2 are 2 points in space, then the line joining or the line segment joining A and B and pointed from A to B is called AB bar. You should read this as and is that okay? Is the video getting buffered for you, for some of you? Is video buffering to some of you? If yes, if that's the case, please say yes. Is video getting buffered to few of you? Suma, is it buffering for you? Okay. So I hope now it's fine. Correct? So see here. So AB bar is given by x2 minus x1 into I bar plus y2 minus y1 into j bar plus z2 minus z1 into k bar, where I bar comma j bar comma k bar are unit vectors. What are unit vectors? Basically vectors of length 1 unit. Vectors of length 1 unit along x, y and z axis respectively. Okay, so now let me draw some diagram to show you this. Okay, so see here. Now let me again draw this three coordinate axes that are available to us. This is horizon, this is x, this is y, and this is z. Actually, z should be something like this, pointing out. Okay. So now if you see, this I, j, k are these vectors which are along this axis. So if you see, I bar is something like this, j bar is something like this, whose magnitude is 1 unit, and k bar is something along this z axis. Okay, so this is k bar. So if you see, this I, j, k form a right-handed coordinate system. So for example, if you see I, j, if you rotate from vectors I to j, this thumb which is here points towards positive z axis, because if you see, practically speaking, if this is x axis and this is y axis, then z axis is pointing out from the board like this. It's like an arrow coming towards, out of the board. So if you see, if you take your right hand and if you rotate your four fingers in the direction of so that your direction goes from I to j, when you are rotating in this direction, your thumb points towards positive z axis, which is same as the direction of this z axis. Similarly, if you take this and if you point out from j to k, generally when you are pointing out, this is j, and if this is k, when you are pointing out from j to k, this is showing positive x axis. So this is called positive right-handed coordinate system because they obey right-handed thumb rule. Okay. So now if you have 2 points, x1, y1, z1, and somewhere here, if you have this point x2, y2, z2, if this point is a and if this point is b, then this vector which is joining, this vector which is joining a to b is called ab bar, and ab bar is given by this. So for which the difference in the x coordinates is given by x2 minus x1, means if you project this point onto yz plane, and if you also project this point onto yz plane, then the difference between the x coordinates, if you project this onto xz plane and if you project this point also onto xz plane, the difference between x coordinates is x2 minus x1. Okay, so if you know, if those are the 2 points, then the length of the segment AB. So if this is the case, then length of AB from those 2 points is generally, magnitude is denoted by this symbol of modulus along this vector notation. So magnitude of this vector AB is equal to square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. I told you this formula during solving a question in concept of maxima and minima in double variables. Correct. So if you see, this is the length and this direction is given by the vector AB is equal to x2 minus x1 I bar plus y2 minus y1 j bar plus z2 minus z1 k bar. Okay. So now if one of these points is origin, for example, if A is origin, O, then if A is origin O, then OB bar is equal to x2 I bar plus y2 j bar plus z2 k bar, because in x2 minus x1, if you put x1 is equal to 0, x2 is the thing that is remained with you. So x2 I bar plus y2 j bar plus z2 k bar is something that you will be getting here. Correct. And magnitude of OB is equal to root of x2 square plus y2 square plus z2 square. So we already have this. So this OB is called, then OB bar is called position vector of B with respect to origin. Okay, so if you have this with respect to origin, so then if you have a 3-dimensional coordinate system, basically where things work out like x, y, z, then if you have any point in space, for example, let us suppose this pen itself is the vector which is showing something like this, then you see clearly this point of this pen is not on the board, correct? It's lying somewhere in space. Then if this is the point that we are talking about, then this OB is position vector where point is given by xyz coordinate, some values of xyz. Okay, so basically, you know, this the coordinate system in 2 axis divides this complete plane into 4 quadrants, correct? But in 3-dimensional coordinates, the 3D system divides the complete space into 8 octants, means 8 boxes. Okay, so see here. Oh, so suppose I can't put a point here, so I'm putting somewhere here. So if this is the point xyz in general, so the vector joining O to this point B, let me call this x2, y2, z2. So this point, let me write the things clearly. So x2, y2, z2, then this OB bar is given by this particular equation, and this specifies the direction of this OB. That since this is x2 minus 0, we specify the direction is from O to B. So magnitude of this vector is root of x2 square plus y2 square plus z2 square. Okay, so I think it's 12:20 now, so we'll end up this class now. So giving some idea on 3D. So in tomorrow's class, we'll continue what are different types of vectors, and we'll see starting definitions of vector point functions and scalar point functions, and then we'll go. And I hope this vector calculus could take around some 4 lectures to finish, some 4 to 5 lectures, not more than that. So we'll complete the things, and we'll look at other previous gate questions and all, and then we'll go for complex variables. Okay, so is that okay to all of you? If you say yes, I'll end up this session today. Okay, is that fine? So okay, then thank you all. So you can see, since we finished 2 chapters already, basic calculus and differential equations, generally from where you will be getting some 4 to 5 marks in gate examination so far. So if you are feeling okay, please comment something on feedback. If there is something you want me to be done, you want me to get done, you can always write there. Vector calculus will take not more than 4 to 5 lectures, Kamluddin. Thermodynamics class is at tomorrow 10:30. I mean, sorry, 10 o'clock. Okay, thermodynamics class is at tomorrow 10 o'clock. No issue. And maths class is, as usual, we have at 7:45. Notes, I have already sent the PDFs to the people, and we'll be sending this differential equations PDF very soon. So no issues. Okay. So is the subject going fine? Are you all understanding the things what I am teaching you, or are you feeling difficulty at any point? I want to know that. Is everything what I am teaching you understandable to you? I want responses. See, 32 people are. No, Ganesh, vector calculus is not completed. We'll be working out. So I hope all of you are giving only positive responses. If there is no negative response, then I would like to end this session here. Okay, then thank you all. Have a nice day.